Hey everyone, welcome to this week's edition of Live Code Tuesdays. My name is Sohan Maheshwar. I'm a dev advocate with Fermyon. If you haven't joined us before, this is a live stream we do every Tuesday at this time where we talk about something in the world of WebAssembly. And this week we have something different. We are going to be exploring Zig and Fermyon Spin with Ethan Holz, aka Ninjatron. Ethan, you have been doing a lot of live streaming on your personal accounts as well. Very cool to have you here. So thank you so much for joining in.
Yeah, thanks for having me.
Yeah. So Ethan, first question. So maybe you can give us a bit of a background about what you do, and more importantly, how you got started working on Zig, and tell us a bit about Zig, basically.
Yeah. So for a little bit of background, I'm a research software engineer for the Open Molecular Software Foundation, and my story with Zig and Wasm kind of came out of before that, where I started writing a parser for protein databank files, which is a file format that we use to do with molecular simulations. And it's kind of a unique file because it has these very interesting 80-character line lengths, which is kind of fascinating to me. But one thing that I started to do is I was like, all right, well, let's write it in Zig. Let's try something different. Let's try something new. We'll write it in Zig. And what that quickly led to was, how could we make this accessible? How can we get this out to people to actually use it? And that taught me, let's pick up Wasm. Let's use Wasm as a way to actually make this more accessible and get it out to people who are interested in using this. And that's kind of how I got started using both Zig and Wasm. I kind of learned both at the same time, and picking up both of them has been an interesting experience, to say the least.
Yeah, that's pretty cool. I think in the Wasm world, I met a bunch of people who, do Rust, for instance, right? And they do it because it's a little more low level, and it does like memory management. And of course, the Spin SDK is written in Rust. I think Zig sort of falls under like a very similar category of programming languages. So yeah, it's awesome that you can be here and sort of share your knowledge and like writing Zig code, basically.
Sure. Yeah, I think that it really hits some of the same. You're right. Like, it hits that systems programming kind of feel to it. I feel that Zig has a little bit. It goes a little deeper, I think, than Rust can. Mainly because you still have to manage all of your own memory, which the pros and cons to that. But it does make for a very different developer experience, especially when we're working with Wasm, and how you actually, some of the things you have to do to manage memory over that Wasm boundary. Zig kind of presents itself as a really great tool for that, because you get the ability to really use those memory primitives to more fine grain manage how you're moving objects over the boundary.
Okay, nice. So I think this is the perfect segue to start like getting into the Zig aspect, right? Before we start showing live code. Yeah, let's do it. So I think first question, right? So do you recommend certain use cases of when or why someone should actually use a programming language like Zig? Right? And I think you're probably the first person we've had on the show who's like, doing things like on the biotechnology, like protein and molecular processing level. So is that like a use case that typically Zig is good for?
Yeah. So I won't speak to that. I don't really know if it's useful in that case. The reason that I picked it, though, is kind of that having manual memory management matters in some cases where maybe you don't care about security as much in certain things, right? So for me, I look at memory safety and like why I would pick Rust as a point of, I need really good concurrency, and I need really good safety on what's actually happening from, like, am I not going to overflow my buffer, is really like what it comes down to. And I chose Zig because first of all, I had a very well-defined spec to go off of, for one. So it's, like I said, 80-character length. It's great. It's a great place to start. But also the other thing is that with Zig, you get the ability to get some of those protections. We have kind of this idea of an allocator interface, which allows us to really pass around how we might want to manage our memory. That allows for you to swap out how you're going to manage it at runtime. Now, why would I use it over Rust, for example? Like, why would I use it in certain applications? Your memory overhead is a lot lower because you don't have the borrow checker. So you can kind of really fine-tune memory if that's a use case that you need. And if you really need good C interop, Zig has a great C compiler. So it hooks into I believe it's Clang, like the LLVM C compiler. So it hooks into that, and you can really pull in all of those dependencies, and it has a really nice system for actually working with C libraries if that's something that you need. So that was kind of why I looked at it from using it on like biotech kind of molecular modeling software. Is there's a lot of libraries out there that are already written in C++ and C, and I wanted to be able to hook into them if I needed to. I haven't really done a lot with it, but if I can if I want to, and that's kind of a big superpower of Zig.
Got it. Okay. So yeah, let's just get into like the basics of like setting up Zig. Full disclosure to the folks watching, I played with Zig all of like maybe a couple of days just before this live stream just to get the hang of it, and I installed it a few days ago, which was version 0.11, and just now Ethan just before the stream was telling me that 0.12 is the latest version. Ethan, can you talk a bit about the setup of Zig and if there's any dependencies you need on your system, all of that?
Yeah, so one of the big advantages of using Zig is it doesn't require any dependencies. All you have to do is go to zigling.org, and you can just download it and set it up. They have a binary you can install, do that. Also, it's available in a couple different package managers. If you use Nix, there's a good Zig overlay for that as well. So that's primarily how I use Zig, is I just use the overlay. And you can just download it and install it kind of similar to how you would install something like Go, for example. You can just install the source and bootstrap it that way. So the nice part is you don't need any external dependencies to actually make it run, which is great.
Yeah, I used the very simple like brew to just install it, and it started working like straight out of the box. So that was pretty cool. Yeah. All right. So, yeah, Ethan, if you want to go ahead and maybe share your screen, we can start talking about exploring Zig on Fermyon Spin, of course. Folks in the audience, let us know where you're watching from, who's in the audience. Love to hear from you again. I typically stream from the Netherlands, but this week I'm in Bangalore, India for a conference. It's pretty hot. It's the height of summer. It's close to 40 degrees, which is a little more than 100 Fahrenheit. So, yeah, definitely feeling the heat here in Bangalore.
Let me pull up my screen for you here.
Mm-hmm.
All right. Linux, don't crash on me today. It's a story of my life. All right, can you see the screen okay?
Yes, if you can maybe zoom in a little bit, Ethan, then we should be good to go.
Yeah, we can. Is that better?
Yeah.
Cool. All right. So, like I said, all you have to do to install Zig, if you are interested at all, we'll pull over a tab here so we can take a look at that. All you have to do, just go to the Zig page, zigling.org, click Get Started, and install. You just download it and extract it, put it on your path, and then you're ready to rock. And for some of the stuff that I'll talk about today with Zig Fermyon Router, which is a project I've been working on with Zig and Fermyon. But that, with that in mind, this one's going to require version 0.12. So if you're going to use 0.12, this will work perfectly with that. It'll be great. And yeah, if you're interested, we'll get started. So a couple things that are interesting about this code base and kind of why I decided to use it with Fermyon. One thing that really drew me to Fermyon was that you can use any WASI compiled language just as long as you use the WAGI spec. And that's kind of what I aimed to do with this project. And it's kind of the goal is to really utilize that spec to handle operations of using Fermyon. So yeah,
and sorry, Ethan, but do you quickly sort of want to recap what the WAGI spec is, or Wagi as we call it?
Yeah, Wagi.
Yeah, Wagi.
So if you've ever used like CGI, where you have like a gateway interface where you're kind of just writing, all of your operations are happening by writing to standard out, or standard, not really standard, mainly standard out, and you put it in a specific format. That's basically Wagi. Is you print out things like, this is the header I want, and this is the status code I have, and you print them out in a specific order to the standard out, and then that'll be what's returned back to the user. And that's kind of what I'm hooking into here in order to actually use Zig on Fermyon, because we don't really have an SDK on Fermyon to do that. But yeah, does that answer your question? Do you think that highlights that well enough, or am I missing something there?
Yeah. I think this sort of CGI reference is all we need, right? It usually gets a chuckle when we talk about like Wagi and like, hey, we're just going back to the days of CGI. There's a nice post that Matt, the CEO of Fermyon, wrote about what exactly Wasm, Wazzy, and Wagi is. Just if you want like a if you just want like definitions of what they are. But yeah, you can check that out if you have like more questions. Yeah.
Yep, it's a very good article. Honestly, it's what I used to kind of break down how I was going to write this thing at all, because I had never actually worked with CGI before this. So Wagi was kind of my first foray into what does even a gateway interface look like? How do I use it? How do I build things on top of it? And so yeah, that was my first kind of dig into it was actually with Fermyon.
Nice. And Bunny is in the audience. Hey, Bunny. Yeah, it is pretty humid and hot. So, I'm getting there. I have the old school fan like right above me. That's probably whirring in the background. You might hear that, but yeah. Cool. Yeah, Ethan, go ahead.
No, you're good. Yeah, so we can just kind of jump into this, and we can talk about. I think this project does a pretty good job of covering a lot of the Zig primitives and kind of what are some of the basics of using Zig at all, and we can definitely hop into that. So, like I said, the first big one with using Zig, you're going to manage your own memory, and with that, you have some. It's a very different kind of workflow than you might be used to when you're using Rust, right? And Rust, you kind of just forget about it. You let the borrow checker handle all of that for you, and you're done. When we're using Zig, you have something what's called an allocator. And an allocator is basically what's the implementation for how you're going to provision and use memory on the heap. So in this case, we're going to use the Wasm allocator. And the cool thing is we can go and actually look at what the allocator is actually going to do. So this is the Wasm allocator source. You have a couple different things like the general purpose allocator, which is basically used to get you some runtime checking so that you guard against things like use after free and a couple of the other common memory errors. It helps to guard against that. With this, we get basically a couple different allocator interfaces. So this one's obviously the Wasm allocator. There's a heap allocator that can kind of pull that out. And it provides you basically a couple different functions, right? So the big one is alloc, resize, and free. So you get different functionality to actually do that and give you memory, kind of like if you're coming from the C world. If you've ever used malloc or something like that, it's kind of like a wrapper around malloc, but it's specific to each implementation.
You're taking me back to my university days, Ethan. I mean, C was one of the first languages that I actually learned, and it's taking me back, saying things like malloc and stuff like that.
Yeah. So admittedly, one reason that I feel really comfortable in Zig is I used to be like do embedded programming. So a lot of my work was in the embedded space. And so using C was very easy. It's kind of like what I did a lot of. It's what I used in university as well. And so using allocators is kind of almost made more sense to me than when I first picked up Rust. But I hadn't done it in so long that when I picked up Zig, I ran into those same issues I was running into of like, oh, I have to actually be mindful of how I'm allocating memory. And I have to make sure that the caller is doing, is handling whatever it gets allocated correctly. And that's kind of, that's kind of been a struggle as I've come back to using Zig is there is all these little things like, oh, I do have to care about this again. That's crazy.
Yeah.
But so like I said, there's a couple things here that kind of happen. So one big one is that you kind of pass your allocator around. So you use an allocator for a use case. So another common one is we have like arena allocators in Zig that we can use to kind of do typical arena allocation type tasks, so that you don't run into that issue that kind of Go has, where you kind of get stuck in that what they decide is the memory model, and similar with Rust. But in this case, you can pass around how you want that to be allocated. And one way that we kind of guard against memory issues is by just having a defer keyword. So in this case, we're saying, hey, we're going to allocate, we're going to pass an allocator, and anything that it allocates after the scope of this function is complete, deinit that function. So then in that case, we're saying, hey, we're gonna deinit any memory that is called there and whatever. And you can use defer and for not just using it in a memory context, but you can use it to to handle any task. Maybe you want to handle an error after the function returns or something like that. This is kind of how you do that. It locks it to the scope. It's really popular for using it with allocators and using it with memory. So the thought is, if I'm going to do an operation where I'm allocating on the heap, put the defer right afterwards to deinitialize that memory so that when it calls at a scope, I'm done with it and it doesn't matter to me anymore.
Got it. Okay.
Yeah. So that's kind of the thought of like, those are kind of the big picture things about Zig that I think are important. That you have to manage your own memory. And because of that, you have to kind of be mindful about how that memory gets freed when you're done with it. But also there's a lot of things available to you to actually make sure that you do it in a way that makes sense for you. So for example, like I said, freeing at the end of a specific block, or maybe you need to wait until it's farther up the chain, you can defer higher up the chain in the call stack. And that makes it a little more easy to work with. So you're not, worrying about like putting a C call somewhere in the right place to catch something. This kind of helps to mitigate a lot of that. Does that make sense so far?
Yeah.
Exactly. Okay.
Yeah, I think so. Yeah.
Awesome. And if there's anyone in the comments that has any questions, please feel free to ask. I know it's a little bit different from the Rust world, and I'd be happy to answer any questions you guys have. So please ask. Yeah, so we can just start kind of looking at this project and like what it actually is. So Zig Fermyon router is there's currently a bug in Zig format. But basically, there's the goal of the Zig Fermyon router was to provide a way to host static sites primarily on Fermyon using Zig. And the reason for that is there is a really cool project called Zine. It's like right here. That is written by Loris Crow, who is part of the Zig organization. That is a static site generator written in Zig. So you get all of that, generates all your files, you provide it, your templates, and it renders everything out. You get a really great experience. And one thing that I liked is it uses the Zig build system, which is the next thing we'll talk about here in a second. The Zig build system to generate all of that. So it generates all your files for you and makes it all nice and pretty. With Zig Fermyon router, my goal was to do the same thing, right? You should have an experience where you can build out a simple router for maybe you have a couple of API routes, maybe you want to serve some static files, make all that work really nice and cleanly for you. And then at the end of the day, it also spits out your spin.toml file. So it'll take the information that you can get from the build system and actually use that to generate everything necessary to actually build and use Fermyon Spin. And that was my goal. It's based on that kind of idea. Let's build something out that we can use to make working with Spin a little bit easier for people who want to write it in Zig. One thing I did mention was the Zig build system. So it's kind of another thing that really sets apart Zig and like how it's used is the Zig build system is meant to replace things like make or something like that. It's kind of similar to Cargo in a lot of ways, but it's a little different because it provides you that really fine-grained tuning, almost like CMake does, to actually go through and really hammer through and be very meticulous about how you're linking and moving things around. This process is just Zig code. So that's an important thing to note, is that when you're writing the build.zig file, it is actually just Zig. So you can write all the Zig that you already learned for writing your application and port that over to actually doing build operations as well. A great example of this is, it's a little bit messy, but the generate spin toml file that I was kind of talking about earlier, that is just Zig code. So it's just a Zig function that takes the standard build steps, that you get from the Zig standard library, and you're actually able to generate files in your build pipeline. So in this case, we're using it to generate the spin.toml file, as you guys might see here. Like, this kind of looks very familiar to anyone who's worked with Spin before. It's using that to actually generate those files, and we're getting that information actually from the build steps itself. So whatever you name your project. So in this case, we're saying we call it Zig Fermyon router is the executable, which is just going to be the WASI file we produce. We actually are able to generate a artifact that is also all of that information. So it says, hey, take that executable, extract the information from the executable, and provide all the rest of the information for actually using this thing, which is kind of a really cool idea, is that you can actually hook into existing Zig code to do build operations. There's some kind of issues with that, but it is, in my opinion, it's one of the coolest features of actually using Zig.
Yeah, and I think this is overall also like a super cool approach, because you're writing Zig code to sort of generate the spin.toml file, right? As opposed to it being generated by like a spin new or whatever. So yeah, I think that's a pretty cool approach.
Yeah, I think that so one thing that I want to do eventually is, like I said, I was talking about Zin, right, and how it's using the build system to generate a static site. So my goal is well, that information is getting exposed about the static site. We should be able to hook into that from a spin perspective to actually use that to hook into generating the spin.toml for the static file, like the static directory that we have to pass in the spin.toml. So my goal is eventually we'll hook into that project as well and provide some sort of, I don't want to say plugin, but some alternative way that you can hook into that system and use that code to actually build spin, or use spin in a way that like makes a lot of sense in that case. So you can build your site, and then it like automatically builds the spin toml file, so you can just quickly test and spin up your instance, and it's all front to back. You get Zig all the way through. Also turtles all the way down.
Yeah.
Yeah, but that's kind of the so to me why I use Zig, and like why I've started using it, especially in a Wasm context, is you get a really great build system where you can just write code to determine what like how things are going to build. Maybe I want client-side Wasm in one place and I want WASI somewhere else. I can do that all in the same code base with Zig. And the other thing that I really like is I do have access to that allocator when I need it, especially when I'm working across the Wasm boundary. Not necessarily as big of an issue when I'm working with WASI, but definitely an issue when I'm working on client-side Wasm. Yeah. But
that makes sense. Yeah, and for folks just joining in, I see a few people have just joined. We do this stream every Tuesday, and today we are exploring Zig with Fermyon Spin with Ethan here. Ethan's done a bunch of cool stuff with Zig and Fermyon Spin, and he also streams from. How often do you stream, Ethan? Is that like a weekly thing?
Yeah, so I try to stream a couple times a week. So try to get 2 to 3, but I've been traveling quite a bit, so not as many. But yeah, 2 to 3 times a week on Twitch. You can follow me at Ninjatron, as it's here on the screen. I guess I should mention the one other big feature of Zig and why you might use it. And it's kind of the one that I think it's a lot of it's the very interesting part of it, and why. One thing that we'll touch briefly on here, I kind of avoided it in this project, but it is interesting to talk about, is comp time. So comp time so Zig doesn't have macros like C does. So you don't have to deal with the macro system. It doesn't have macros like Rust does. Rust macros, I think, are a little more powerful than C macros, obviously, but you don't have that kind of reliance on macros like you do in C, even though you get all the C compatibility. And in Zig, we have something called comp time, which is kind of a similar idea in metaprogramming, where you have information, you have code that only runs at compile time, and then that generates, code for you at compile time. So whenever you see comp time, you can just think of that as there's something that you are building and it's going to generate some code for you. And there's a lot of cool places where that's the case. I don't think I use that at all in this one, but there are some really interesting use cases for using comp time.
Okay, and does this replace like the concept of a macro in either C or Rust? Is that?
Yeah, it's kind of similar, but you get all the type safety as well. So like typically in a macro, especially in C and sometimes in Rust with like maybe a proc macro, the type safety is kind of, you hope for the best. You just kind of hope that it works out. In Zig, you get to reuse all of your type safety. So it's just kind of an abstraction on top of the language itself. So it just can do all of that generation for you ahead of time. But yeah, that is a cool feature. I don't cover a lot of it here. It is kind of the Zig redeeming feature. I think it's one of the coolest parts about it, but it's also the one that will probably take you the longest to wrap your head around in terms of what it actually does and how it works. So it's a very cool feature. Would recommend people take a look at it, just because it is very different from macros in both C or Rust. All right, so what do we want to take a look at? Where do we want to just dig into this code here? Do we want to keep looking at this or
Yeah, I think we should do that. Yeah, okay. We can maybe spend some time looking at this. I know you're also working on like another project, which maybe we can talk about a little later as well.
Yeah, we can talk a little bit more about that in a second. So like I said, the goal of this project, provide you a way to write API routes using Wagi and also make it look like Go, because I used to be a Go dev. That's it. That's the win. That's what we're going for. And yeah, so what you do is you get this kind of Go-like interface with just request response. It returns a type, or it returns this information. You get kind of these interfaces for actually getting information, and you can spin up, everything here. So like a really great example of this is like your test handler. We added scoped logs a couple days ago, so you can enable that. But you get this kind of response.write interface, adding headers as well, and that's kind of what how you go down that rabbit hole. And just to kind of take a look how we can start peeling back the layers and looking under the hood on like how this actually works. We start with the router, which is just our, it's just a hash map of routes and, a handler for not found and an allocator. And that's really it. That's all you need to get a decently working router that just does kind of the minimum of like, hey, I have some things I want to route them. It works pretty well. So we start by kind of the initialization kind of things. This is similar. The one big one here is dinit, right? Which is basically when we call dinit, that's going to handle your freeing of your hash map. So some of these functions have, if we look at the string array hash map, it has a function to, this is a comp time value, which is kind of an idea. Comp time is somewhere between macros and generics. That's probably the best way to put it, is it kind of does a little bit of both.
Is this like a Zig specific thing? Comp time? Yeah.
Yeah.
Okay. Yeah.
I haven't seen it anywhere else, but it is kind of it's how Zig is able to generate code for in a generic context, right? So if we have a function, like let's say in this case, right? So we're looking at a array hash map. We don't know what the types are. We also don't want the standard library to have one for every single type that it could possibly be. So in this case, you pass a comp time type and a comp time value, and then this will kind of propagate through, and it'll generate a array hash map type at compile time, so that you can actually use it for whatever you need to do. So you can make it work like a macro, but you can also make it work like a generic, and it's
like a generic. Okay.
Yeah.
That's interesting. All right, very cool. Radu is here. Radu is the CTO of Fermyon. Also someone I personally rely on to tell me about the latest and greatest in tech, because on Slack he's always like, hey, check out this framework and stuff. So thanks for joining in, Radu. I wonder if Radu, have you done work in Zig, or have you played around with Zig? Radu's like our resident expert on like new languages, frameworks, that sort of thing.
For sure.
Oh, I think we got a big bunch of people just joining into our stream right now, folks. This is Live Code Tuesday. We stream both on Twitter and YouTube as well. Today we are exploring Zig and Fermyon Spin. We have Ethan here, who apart from his daily job as a software engineer at a biotech company, is that an accurate way, Ethan?
We're more of a nonprofit, but
okay.
Yeah.
All right. Yeah, Ethan's also a streamer, so check out his Twitch at Ninjatron, as you see on the screen. Yeah, Ethan, over to you.
Yeah. So where we were is we were just kind of chatting about what are like how does this work? How do we use a router? How would we build one in Zig? This one's kind of basic in terms of we're just using a hash map, and we were talking about how comp time kind of enables us to have some semblance of generics in Zig. So yeah, that's kind of it. You get this ability to add routes and create static routes and kind of go that direction where you can just add things as you would. It takes function calls, whatever. You can specify things like what kind of methods you want and whatnot there. You also get to use things like any type, which basically allows us to do kind of a type inference idea. So kind of similar to, maybe I don't know what the type is, but if it has all of the methods, like it can match the interface, then that's good enough for us. And we use this in the case where, like right here, where we can say, hey, I want to match on post, but also I want to match on the standard version of the standard HTTP method from the standard library. We want to match on that. This allows you to kind of specify how the developer wants to do it rather than me telling you how to do it. Like you can choose what you want to do. And if it works for you, then that is great. And that works for me.
Nice. Ethan, if you don't mind, can you drop the link to the repository?
Yeah.
If it's around, yeah. We can share it with everyone if anyone's interested in checking out the repo and playing around with it.
Yeah, should I just drop it in the chat here?
Yeah.
Okay. Yep, I have it up. Let's see. Put it right there. I dropped it in the YouTube chat. I don't know if that it's like wanting me to connect. Hold on.
Okay. Yeah. So sometimes YouTube is little, let's say, careful with links on a live chat, and they mask it. So in case that doesn't work, you can drop it on the private chat, and I can share it through StreamYard, which is what we use to stream.
Yeah. Here, let me. I'll put it here.
Sounds good.
I was just asking a lot of me there. Okay, there we go.
Sorry.
Nope, it's good.
Yeah.
Has failed to post for me. Okay, I'll just send it to you. Here you go.
Yeah, that's fine.
Yeah, there you go.
That's good. Yeah, and folks watching, I'm just posting this link on the YouTube chat, so feel free to check out the repo. Yeah, there it is. Ethan's also been streaming him building this router on his live stream, so that's pretty cool. That's how I came across Ethan and the sort of cool work he's doing on building like a Zig Fermyon router, and that's how we got connected. So yeah. So Ethan, I also got to know that you're working on like a very cool project in like the biotech side of things, right? Which
so
I'd love to talk to you about.
Yeah. So we'll talk a little bit about that. So my parser that I kind of alluded to earlier at the beginning of the stream was kind of what is how I got my start in exploring Wasm, and we built that out. My goal was, and then I can show that as well. So this is also a project I built Fermyon router to build this out, to like actually develop and use this here. Like that was the whole goal. Like we'll use Fermyon to host this site. I'm going to note a couple things about it. So we pull over the URL. All right, so it's super basic, but you get the ability to take one of these big PDB files, load it up, and it converts to a fast file. Now, there's a couple things I want to highlight here. If there's anyone watching that actually does molecular modeling or does anything with PDBs, this is not exactly accurate. I found a repository that does something similar to this, and it does not capture all of the potential residues that you might have in one of these files. So generally a PDB, the best way to describe it as a protein databank file is basically a file that contains all the information about a protein or like what's going on there. So you have like a bunch of different structures that are kind of coordinates to where atoms might be in a given space. And one file format that you have is the PDB, the protein databank file. But you also have FASTA files, which are used more like in biology, kind of more, I see a lot in like synthetic bio. But what it is it's kind of, it takes a bunch of the sequence variables and puts it into like that long string that I just kind of highlighted. So what it does is it takes those atoms and puts them into like, or the residues rather, and puts them into a string. The implementation I have here only does the first residue. So you can have multiple residues in it can take multiple parts and put them in a FASTA file. This one only does one. There's actually a better way to do it, but like I said, I just took C code that I saw and I was like, let's port this. Let's build that out. Let's do that. But my goal is I saw that site up and I said, all right, cool. That's great. But it's running like a Java applet, I think. And I was like, come on, we can move past this. We have WebAssembly now. We can do this, people.
Yeah.
So
thanks for saying that, Ethan. I'm going to cut that clip out and put it everywhere. Yeah.
As you should. Yeah. We have WebAssembly. Let's use it. We can compile any of these languages to what we want to do. First of all, kind of it presented a challenge. How do we actually use this to? First of all, how do we build it in Zig? How do we build a parser that actually can, first of all, parse PDBs, and then secondarily, how do we use it to build out and use those PDB files in a way that's meaningful? So that's part one. Part one was let's build a cool PDB parser, which I'm still actively developing on. I actually have a sister parser that I wrote when I hit a performance wall in Zig, and I wrote it in Rust. So you also have it written in Rust if you want to do that. Also compilable to Wasm. Very cool. With the goal of providing eventual Python bindings for both of these. Mainly because it's still the language of scientific compute, and we need it there. Like that's where people are going to use it. So we need to make sure that we have the ability to compile down to Wasm. And yeah, that was kind of the big idea behind why I'm gonna why I use it. So I had that site, right? And I was like, okay, cool. Well, how are we going to build this out? How would we do this using just Wasm? And at the time, I hadn't written any client-side Wasm. So I was like, oh, well, we'll just use HTMX and Wasm and Zig to handle that, right? So we just write an API route that just returns back the HTML that we want, and we swap it in using HTMX. And that's how we can go ahead and do that. So that was the initial implementation. And that's, we have some code samples, I think, that show that still. Yeah. So it's taking the PDB project, which is typically an x86 project, and we're rewriting it to use Wasm. So it cross compiles to Wasm using Zig. And then we were just using that to generate these and kind of swap it into a div. Pretty simple project. Like it's a pretty easy thing to do. And that's great, right? That's super simple. It's awesome. I go, well, we have all this power. We can write client-side Wasm too. We can ship it to the client, and then they can use it forever. But also, we can host it back on Fermyon. So let's do that. Like, how do we do that? And so that's when I went down the rabbit hole of building out the idea for what if we just built client-side Wasm. You ship client-side Wasm to do all the parsing in the browser, and then we can use Wagi to host it. And the big reason I did that was sometimes I was uploading too big of a file to Fermyon, and they would say like, you guys would be like, hey, your file's too big. You can't be doing that. And I was like, wait, fair enough, understood. I understand that. That's fine. And so what we did instead is I said, all right, well, we'll run the backend in Wagi, and then we'll run the front end in Wasm. So that's what we're doing here. If we look at, it's not here because I haven't committed it yet. Basically, what it allows you to do is we write We're using that same PDB library, that same protein data bank parser. We're going to use that, and we pass it in. We're gonna pull in all of that data that we used and we wrote in Zig for x86. We cross compile it, pull it in as a dependency in Zig here, and then we can just export it and send it right back out. And the code actually looks almost exactly the same between what we were going to do in Wagi versus what we're going to do in like client-side Wasm. The only difference is that we're not going to swap divs or do something like that. We're going to be a little more dynamic in that regard, where you have to actually work with the DOM. But that's the big difference.
Man, that is very cool. Yeah. So just from a project point of view, whereabouts do you think the project is at, right, in terms of like completeness, that sort of thing?
Yeah. So for Zig Fermyon router, I think it's pretty much complete. I think that's in a spot that if you guys want to use it, feel free, please do. Submit PRs, let me know. I am very open to you breaking it and giving it a shot. That one, maybe a couple docs changes and we're there, but it's good enough to work. It's feature complete if we're going to do it all over Wagi. The only thing we don't have is any support for the Spin SDKs. So if you want to use any of the Spin specific functionality, we can't do that. But even if that, there's some hope on that. I can show that in a second. We'll finish answering this question. We can go back to some work happening on Spin SDKs for Zig. So that's cool. That's I think Fermyon router, great if you want to host a static site. It's ready to go. There's an example of actually hosting the Zin static site docs on Fermyon, so that's already up and running. You can test that out today. That's the first one. The second one on these PDB parsing, the PDB libraries, both the Rust and Zig, they're not done yet. They're very experimental. They're still very likely to have major breaking changes. I'm currently completely rewriting that parser from the ground up in Zig with actually I'm quite proud of this. Actually, I finally managed to break the speed of concurrent Rust, and that was kind of a big problem. It was like, well, I have to write it in Rust because concurrency just works so much better in Rust than it does in Zig. It has all these great concurrency primitives, but I wrote it in Zig, and it was slower. But I finally managed to get away to get the memory to work in a way that is faster than Rust. So we'll see. Those projects, I would say, very, very alpha. Don't use them unless you want it to break underneath you. And also the way that I have kind of built that out is they have no bindings to Python yet on purpose, so that you can't use it in a way that's actually meaningful. And I don't make sure I don't do something and then someone can't do their PhD because I wrote a parser they can't. That broke underneath them. I don't want to be that guy. So
yeah, someone's worked 5 years on like a project, and then
then they go to publish it and the thing doesn't work. Yeah, no, we're not doing that. So that's kind of the status of that project. It's still pretty alpha. I also stream that one too. So if you guys are interested, I have a lot of content on that. Feel free to come stop by, and more than happy to talk about it.
Awesome. Yeah, I think, from what you told me right now during the stream and when we spoke before the stream, it looks super cool. And I'm excited for how that goes. Any reason you chose Wasm specifically for that project, Ethan, about,
Sure.
doing this parser for a protein? And you did mention that you also wanted to learn Wasm and try it out in Zig, etc. But from a tech point of view, was there a reason you chose Wasm for this?
Sure. So the biggest one is that, to me, I think Wasm is the ultimate way for accessibility, right? When I want to get code out to people, having something that can target Wasm is a huge deal, because if we have Wasm code that's out there, if it can compile down to Wasm, you could run it on a smartphone. You can put it, wherever you can run Wasm. Now we can put that code anywhere, which is not necessarily the case. Generally, when we're talking about targeting something like x86 or ARM or something like that, with Wasm, we get the ability to actually really put code wherever people are. And that was my thought, as I said, okay, well, if we want to get this out there and we want it to last for a while, we want it to be able to hey, maybe the programming language of science today is Python, but maybe tomorrow it's something different. Maybe it's Rust or something like that. By having Wasm, all it requires is I just need a Wasm runtime somewhere, and then I can run my code anywhere, which is kind of a big problem, I think, in a lot of when we look at scientific computing, is you run into this issue of we have code that was written in a language, and now the language is kind of fallen out of popularity. But there's a lot of good code out there. But why are we going to rewrite it all if it works completely fine? I mean, there's some times where you do, but for me, it's like I want it to be accessible. I want people to be able to use it after I'm gone with it, after I'm done using it. If it still works, you should have the ability to run it. And the way that I see that we do that is it needs to be able to run in Wasm. If we can run it in Wasm, then it's good for the future of people who want to use and run that code.
Yeah, I think that's super interesting. And Ethan, have you spent time looking at the component model in WebAssembly, right? Because I think that is like the sort of perfect description or use case of why the component model makes sense, where it's exactly what you said. There's so much good code out there, but not necessarily in either the language or the platform that you need. But in cases like the scientific community, you can just reuse that piece of code, right? And it's having the component model, which if you're not familiar with, you should check it out. You can actually just have something compiled to Wasm and reuse that component in your program written in whatever language you're writing in, which could be the language of the future, right? And I think Bunny is also saying something very similar, which is agree 11%, good Lord of the Rings reference there, that Wasm is a great universal compile target. Like if you want like blazing speed, you target the raw metal itself, but you get the easy distribution with WebAssembly.
Right. But I think the other thing is it kind of provides a really good path for maybe I don't want to target a C ABI anymore. Like a big problem, right? Especially when you're writing code for Python, is if I want to write C or C++, I need to target the FFI, right? I need to write code that does that. And same with Rust, right? There's some great projects for writing Python FFI. Let me be clear. Like Python FFI in Rust is awesome. It is so nice to write. But a lot of those projects that maybe you need some FFI, maybe you're just going to like write a little file parser, maybe you're going to do maybe a one-off task, maybe reaching for a Wasm runtime isn't the end of the world. Maybe using, something like Wasm time to actually handle those calls makes a lot of sense for a lot of use cases where, hey, maybe I have some code that I want to run. Yeah, maybe that works. And it's good for the start, but then you're right. If I want that blazing fast speed, then I'll reach for the raw metal. But maybe I just want to try it. Maybe I just want to see if it'll work this one time. Well, yeah, then maybe just use a Wasm runtime, see if it works.
Yeah, fully agree. And I think with the release of Wagi Preview 2, you have the ABI for the component model, right? So I'm super excited to see how that actually pans out. I think there is, from a Bytecode Alliance point of view, there's some work that needs to be done with regards to like the dev experience, with regards to building out registries, which do exist right now, but they're very like sort of new. But there's just so much that's going to happen in that space that I'm super excited to see how the component model actually evolves to getting to that stage where people like you and me, we can use this on like a day-to-day basis. Yeah.
Right. And Wagi Preview 2. I'm really excited to see more about and get more of the component model. It's something that's kind of not quite there yet in Zig. It's the development around it has started to kind of pop up, but it's really not quite there. And I would like to see it there because I think that if we could get that, it would make Zig almost a no-brainer for writing Wasm code. I think it could be really, really powerful, and it would make actually using Zig with Fermyon a lot better. Like it would be a much better experience if we had access to Preview 2 and some of like the things that came with that. And I'd love to see it. I think that would be awesome for the Zig community.
Yep. Agree. Switching gears slightly, you mentioned that there were a few things that you were working on with the Zig Fermyon router, right? And I'm going to bring up your screen.
Yeah.
So let's maybe quickly talk about that before we wind up our stream.
Yeah. No, that's a great call. So like I said, one thing is we're working on getting those integrations with Zin, the Zig static site generator. That's a big one. PDB to FASTA Wasm is kind of the other one with that. And kind of this project here is the biggest thing I'm working on for actually working with the Zig Fermyon router. There's a couple things that still need work around the Zig Fermyon router because of Wagi. Like, because we're using that, it can be a little problematic. It doesn't really give you a lot of functionality. It kind of just, it's pretty simple. But yeah, that's kind of the big one there. There is a project I want to shout out that I am looking at using in the Zig Fermyon router down the line. So this one is basically a working product Zig SDK, and how this is working is it's using the like the WIT worlds. So it's using like WIT code and then using WIT bindgen to generate C headers and source code. And we're using that actually, or that's being used here to generate Zig bindings. Ideally, I would actually eventually like to just use this instead. There's a lot of questions right now on packaging. So using the Zig package manager to like distribute that. That's where I want this to go. Like, I want Zig Fermyon router to eventually transcend using the WAGI spec and use this instead. And that's kind of my next big project, is we're going to start figuring out how to use Zig Spin to actually build this out and get all the dynamicism that you get of using Spin. So things like outbound requests, inbound requests, config. Ideally, you guys just released MQTT support. I really want that for my own reasons, because I need it for my smart home. But
coming soon. Yeah.
Coming. Sorry, I've seen it around. Okay, I've seen it around, but that's what I want to do is use that there. I think that'd be really cool.
Very cool. And I see that you're working on this with.
It was a docs change. It was a docs change. let's not sell it. Okay, like I don't want to oversell it here. There's some questions about actually using the packaging in Zig. So we just got a package manager in Zig 0.11. 0.12 is out now. But there's still a lot of questions on how to package things. And I think the thing with this one is they're generating the use bindgen to generate the header files at build time. So if you don't have them on your system, it'll generate them for you. And then that's kind of one of the things here. I think one thing might be, it's just kind of like how the Spin SDKs do it, which is just kind of vendor in the generated header files and use that instead. We'll see. There's a couple of different ways this could go, but it's a project that I think is really well written. It's really nice for like what it's doing, and I really want to give it a shot and see how far we can move with it.
Yeah, that's awesome. I'm also super excited to see how this pans out. And for folks just watching in or who aren't part of our Discord, we have a Discord server. Do join there if you have questions about this or Spin at any point of time later. All of us hang out there all the time, so we're nice people, I think. So we'd love to help you out. Yeah,
I lurk there as well. So if you have any Zig questions about using it with Fermyon, feel free to @ me, and I'll do my best to answer any questions you guys have about Zig and Fermyon as well.
Sweet. Okay, Ethan, so we're almost out of time. We have maybe 5 more minutes for our scheduled stream. What are sort of future plans for both the projects, right? I mean, we spoke a little bit about it earlier, but I mean, I hope you'll be streaming a little more about, building these things out. But any big things you're looking at building or integrating with the projects that you spoke about?
Like I said, this is kind of the next big thing to tackle right here. There's still a lot of work to be done on making the experience of shipping client-signed Wasm easier, and building that out in Zig. So kind of my next steps here are we're going to try and use WIT bindgen to kind of handle some of the requests that we can receive on Fermyon. That's the big one. I really want that to work, because I think that if we could get that built out, it would enable a lot of really nice development for people who want to use Spin and Fermyon, and it could be a really great option for if you have something you want to hammer out. That's the first one. The second one is I'm currently iterating on my PDB parsing work to be a little more crazy. as it were. So we're in the process of moving that all out from using like I guess the Rust equivalent of like a stir, like kind of like not a string, but like something with a length and a pointer. We're currently in the process of converting all of that to variable width ints and using that. That one's going to be upstream, but it's very low level. It's actually it's kind of a headache. So we'll see how much streaming that actually happens, because it's like juggling mentally with working on that. So we'll see about that. But also it should make it a lot better for actually use with Wasm as well. It should make it a little bit easier to use in client side Wasm cases.
Nice. Yeah, I'm looking forward to seeing the trajectory of those two projects. I think we had two firsts on today's live stream. I think for the first time we spoke about something like protein parsing on our live stream. Usually it's about like Rust and stuff like that, so very different. So that was cool. And also the first time we spoke about Zig, which was awesome. I learned a ton as well. So yeah, very cool.
I'm really happy to hear that. Like I said, it's a great platform. I love building on Fermyon. It's been really great to learn how to use it and do that. So I appreciate that. One thing that I do appreciate is that you do implement Wagi, that I could sit here and actually build on top of your platform is awesome. So I really appreciate it. I really appreciate that we could sit here and talk about proteins today, because it's kind of a hard thing to talk about with a lot of developers.
Yeah.
You say protein and they're like, I don't lift, man. I don't I don't do that. So it's kind of a cool thing to talk about, and I appreciate having the ability to talk about that today.
Awesome. Well, folks, if you enjoyed this stream, Ethan streams a few times a week at twitch.tv/Ninjatron. I think it's the same name on YouTube as well, if YouTube's your jam.
Yep.
Yeah. So do follow Ethan there.
Awesome.
Yeah. Folks, I think we're out of time. And first of all, Ethan, thank you so much for doing this. We'd love to have you on a stream again to like have a follow-up on both of these projects at some time in the future. So
sure,
do join us. Yeah, all right. And folks in the audience as well, like Radu, Bunny, and a few others. And folks on Twitter as well, thank you for joining in. Next week, we are streaming with Divya from SUSE about SpinCube and Spin on Rancher desktop. Change of scene from Zig and protein parsing, of course. But we're getting into, actually doing things on Rancher desktop and Kubernetes and that world. So join us again then. And thanks for watching us today. Until next week, see you soon. Bye.
Thanks, everyone.